Each passenger on ABC Airways flight chose exactly one beverage from tea, coffee, or fruit juice. The results are shown in the table below. We have male, female, we have tea, coffee, fruit juice, and then the totals. 13.1 says write down the value of A. We can see here that 60 is the total number of males, and then 100 is the total number of females, and then A is the total number of males and females. So we say in 60 plus 100, which is equals to 160. Or you can add these columns going down. You're going to have 60 plus 80 plus 120, which is also equals to 160. And then 13.2 says determine the probability that a randomly selected passenger is male. We know fully well that the probability of event A is equals to the number of ways A can occur divided by the sample space, right? The sample space being the total, so to say. So we want the probability of selecting a passenger that is male. So how many males do we have? We've already established here that we have 60 males, right? Is the total number of males. So we're going to have 60 divided by the total number of passengers in the flight, right? So we have 60, which is the males, plus 100, which is the females. So the probability of picking a person in random and that person being a male will then be equals to 3 divided by 8, which you can convert to decimals and even a percentage. 13.3 says given that the event of a passenger choosing coffee is independent of being a male, calculate the value of B. So keyword independent, right? So if we have independent, then we have situations where the two are dependent. So let's address independent first. So if the events are independent, then the probability of A and B will be equals to the probability of A multiplied by the probability of B. But then if the events are dependent, and the probability of A and B will be given by the probability of A multiplied by the probability of B given A, right? Given that A occurs. So here we have an independent event, so we're going to stick to this. But then if we had a dependent in a different situation, then you do what we say in here. So let's go to our table and look at B, right? B is the probability of a male choosing coffee. So probability of being a male and choosing coffee, it will be equals to the probability of being a male multiplied by the probability of choosing coffee, right? From our formula here for independent events. So we have B divided by the sample space, which is 160, being equals to the probability of being a male. We already said that that is 60 divided by 169. So we have 60 divided by 160 multiplied by the probability of choosing coffee. So let's look at the total number of people that picked coffee, right? So we have coffee here, and then we just go on a straight line, and here's the total. So 80 people picked coffee. So we're going to have 80 divided by 160. So we're basically solving for B. So we're going to have B being equals to 60 divided by 160 multiplied by 80 divided by 160 multiplied by 160. We're multiplying by 160 on both sides so that we can find B. Yeah, so basically we're going to have B is equals to 30.